Everyone. In the end of the last video on similar triangles, I talked about this specific case here where we have a right triangle. So the big triangle here is a right triangle, and I draw an altitude line through it. And my claim was that this is a collection of three similar triangles. So if I think about this right triangle is having three angles. I've got alpha, beta, and then my right angle here. If those are my angles, then I can start marking them on this triangle here. So this would be alpha, beta, and then the right angle. If this is beta and this is a right angle here, then this angle on the inside must be alpha, and similarly over here, this angle must be beta as well. So what we end up with are three triangles. I'll go ahead and mark them here. All of them having the same angles, alpha, beta, and that right angle. So here is one of those triangles. Here's a second one. And then, of course, we've got the whole thing that ends up being the third one there. So I'm going to refer to these as being the small, medium, and large triangle in this setup here. And we, of course, know that we can use these relationships for similar triangles to find missing sides. So, for example, if we had something like this, where this was 3, and this was 5, and this was 10, and this was x, we would know that x was equal to 6 because we can set up, x over 3 equals 10 over 5, or we could say 10 over x is equal to 5 over 3, right? A lot of different combinations of things we can do with similar triangles. But since there's three of them here and we might need information from any one of them, I like to take those three triangles that I outlined and just line them all up so that they've got the same orientation here. So what I mean by that is, let's say I've got the one right triangle here, and then that's my smallest one. And then I'll put the medium one right next to it. And then the largest one I'll put. So this would be the whole thing, right? The reason I'm setting them up this way is so that I can say for each of these, I've got alpha, beta, right angle, alpha, beta, right angle, and I just find that helps me keep track of everything around here. So I'll give you a second to look at these three triangles, see if you can figure out where the side lengths go on here. If you want to pause the video and try to figure that out, that'll be a good practice for doing this on the exam. But yeah, between this 3x and the 7 here, see if you can figure out where those side lengths go. Okay. One trick that you can use is, so I'm going to use this medium triangle here. I'm trying to figure out where this x goes on here, and I would say this x is opposite the alpha over there, right? So because it's opposite the alpha there, that means it's going to go right there. So let's see, x goes there. 7 is the hypotenuse of the medium triangle, and it's also this side opposite beta in the large triangle. 3 is going to be this side over here, and it's also going to be the hypotenuse of the smallest triangle, and then this side here is going to be x, and I think that's everything that we can put into this. Okay, so we know that we can solve for x using some of these relationships between the sides of a similar triangle. So if I start to try and make some formulas here, I could say something like 3 over x. I'm using this triangle here and this triangle over here. So 3 over x would equal 7 over, and then I would need this thing here. So that's not going to work. I could try something with these triangles over here, right? So something like 7 over x. So 7 over x is going to be equal to, so now I need this thing over here. 7 over x is going to be equal to question mark over 3. So in order to think about the next step, we're not going to be able to do it in one step, but this one, as opposed to what I just laid out the last time, we can actually pretty easily figure out what this missing piece is here, simply because we've got a 90-degree angle here. So we've got a right triangle, and we've got two sides, 3 and 7. So let's figure out that value y, just to give it a name. So we know that 3 squared plus 7 squared is equal to y squared. So that means that y is going to be square root of this. So it turns out that y is equal to 7.61. Okay. So now we can use that information to set up a new equation here where we've got 7 over x is equal to 7.61 divided by 3. So that's using 7 over x is equal to 7.61 over 3. Okay. So this means that x, if we cross multiply here, that's going to be 21 divided by 7.61, which is around 2.76. And looking at our original equation here, 2.76, that matches just about where we would want that to be. Okay, so yeah, I think that some of you may be thinking you can do this in your head without having to draw these 3 triangles out here. But I would say that this is the way that I've found to not make as many mistakes in here. Okay, so that was it. I just wanted to show you a example of this specifically. I'll see you in the next video.